Okay, so this is going to be the second part of 2.2. So we barely started 2.2. So this is going to be the main part that I want us to really get the hang of. So we're going to simplify these rational expressions, fancy word for saying fractions. Okay, so rational is just a fancy way of saying fraction. Expressions. To do so, what we want to do is factor the numerator and denominator and then cancel out any common factors that we find. So this first one's pretty basic, and you've actually done problems like this before, so we're just going to kind of refresh ourselves on this a little bit. So 10 can actually factor into, 2 times 5, and then I'm going to go ahead and you'll notice I have x to the fifth on top, and I've got x squared on bottom, and I'm sure y'all know how to simplify that, but I'm going to do this kind of a different way. I'm going to break that into x to the third times x to the second power. Now that's the same thing as x to the fifth power. If I use the product rule, it would go right back to x to the fifth. So you'll see why I'm doing that in just a second. So on bottom 25, we could break that up into 5 times 5, and then I do have that x squared right there. Now the way this works is you want to factor everything. Basically, you don't want any addition or subtraction unless it's contained within parentheses, okay? And so that'll make more sense as we kind of start to work some of the more complicated problems. But you'll see me keep referring to that if there's any addition or subtraction, you want it contained within parentheses. Okay, so here, once you do factor it though, we want to start canceling out our common factors. So I'm going to cancel out a 5 here, a 5 here. I can cancel out, so the reason I broke that 5 apart was so that now I have an x squared and an x squared. That's not the only way you could have approached that, but that's going to be a similar approach that you're going to see moving forward, so that's why I did that. So what we're left with is 2 times x to the third power on top, and on bottom we just have that 5 right there, and that's our answer. Okay, now you might think, oh, I've done problems like this before, I can do them faster than what you did there. That's fine, but you'll just kind of see as we move forward, that's going to be our approach. Okay, so looking at 6, this one is actually a trick question. The most common thing that students want to do is they want to be like, oh, I cancel out the 5s, but that's not right, okay? Because the thing is that 5 is dividing into the whole numerator, not just the 5x, but also the minus 1. So you can't just divide the 5 into this 5 and leave the minus 1 out of it, okay? If you really wanted to, you could break it apart and divide them individually, like that if you really wanted to, okay? And then you could cancel those out and you'd be left with x minus 1/5 if you really wanted to do that, okay? But honestly, you can actually just leave it like this, okay? You could just leave it like this, but don't start trying to cancel out like that. So remember I had mentioned you want the addition and subtraction contained within parentheses. So what you want to do is put your factors in parentheses. And so then that factor, it's either all or nothing. It either has a common factor on the other side of the quotient line that it can cancel out with, or it can't, okay? So in this place, we can't. So I would just leave it like that. Okay, so looking at 21, you can see it's kind of similar to 6, okay? So you have a 9 in the denominator spot, and so once again, a common thing to do here, students want to cancel out those 9s right there. But we can't do that. So what we'll do is, because you've got that stray subtraction right there that I'd referred to earlier, so I'm going to put parentheses around the top. So see, now it's either all or nothing. Either I can cancel out everything in the parentheses with something on bottom, or I can't. I can't. But what I can do is I can factor the top, though, okay? Now, if you look back at 6, I couldn't really factor anything out between 5x and minus 1. But here, I can go ahead and factor out, it looks like a 9 on top. So I'm going to factor out a 9. So now I'm going to have 9 times a minus 3, and then all over 9. So now it's been factored into multiplication, okay? And so see that that a minus 3, that minus is contained within the parentheses. So now I can start canceling out anything in common I have. So I do have 9s that can cancel out, so I cancel those out. And then all I'm left with on top is the a minus 3. And actually, I don't even have a fraction any longer because those basically reduce to 1s right there. You can keep the parentheses or you don't have to keep the parentheses. So it's kind of up to you. Okay, so the next one, oops, oops, jumping on me. Okay, so the next one is very similar. So once again, don't start trying to reduce the 21 and 12 or with the 15. What we want to do is put parentheses around this and find what we can factor out. And so between 12 and 15, it looks like we're going to have a 3 in common. And so that'll leave us with 4x minus 5 all over 21. And so what we can do here is the the 4x minus 5, it's either all or nothing inside that parentheses. So either that can cancel, either you have the same thing on bottom or you don't, and we don't. So we're going to leave that alone. But the 3 and the 21 are both reducible by a factor of 3, so we're going to reduce that. 3 to a 1 and then 21 to a 7. So our final result, you're going to have a 4x minus 5 all over 7. Now, you don't have to put the top in parentheses if you don't want to. You can just leave it like that if you'd like. You can if it makes you feel more comfortable that you're not going to accidentally cancel something out when you can't. Either way, it's fine. Okay, so our next one. So once again, a common mistake students will make is they'll be like, oh, 4y cancel out, the 12s cancel out, and then they get a little confused because they're kind of unsure what's left behind. Well, first of all, we can't do that, okay, because you've got a minus and a plus, and they're strays right now. They're not contained. So let's contain them. So we'll contain it here and here, okay? And remember, it's either you can cancel out with the exact same or you can't. And there's a big difference between plus and minus, so you cannot cancel these out. They do not cancel each other out. But what we can do is factor out a 4 on top, and that'll leave us with y minus 3. And then on bottom, we can factor out a 4, and that'll leave us with a y plus 3. Okay, so then now we can cancel out the 4s, okay? And those just basically reduce down to 1s. And so all you're left with is the y minus 3 over the y plus 3. And you don't have to put parentheses, but be careful because do not cancel out the y's, do not cancel out the 3's. You just want to leave it like that. And so if you want to, you can always just add parentheses to remind yourself that, you know, it's either all or nothing. So it's up to you. Okay. So as we move forward, it's just going to be more of the same. We're just going to factor, and then after we factor, a lot of the stuff is going to cancel out, and then whatever's left behind, we're just going to write it. So if you look at our next one here, you have the difference of 2 squares because this is the same thing as t squared minus 4 squared. So we can factor the top into t plus 4 and t minus 4. So that's the top. And then on bottom, you can see, you know, if you're doing what multiplies but add to the middle, you're going to get a t minus 4, t minus 4. And you can keep them separate or you can write it together. I'll just go ahead and write it out twice. So t minus 4. And so you notice you have a t minus 4, so you can cancel this one out with whichever one you want. It doesn't make a difference. So we'll cancel out here. And what we're left with on top is a t plus 4. And then on bottom, you have a t minus 4. And once again, you can add those extra parentheses if you're worried that you're going to start doing something you shouldn't. But anyways, up to you. All right. So let's see. Last one on this page. So let's see. We're going to factor this. So let's see. We need to figure out, you know, what multiplies to give us 8, but add to give us negative 9. So I believe it's going to be a minus 8 and a minus 1. So once you factor one of them, it kind of helps you out with the other one because it kind of gives you an idea. You got to have a matching to most likely reduce. Okay. So here we're trying to figure out what multiplies to give us negative 4, but add to positive 3. So that's going to be x, let's see, I believe it's going to be a minus 1 and x plus 4, right? That sounds right. Yeah, multiplies to give me negative 4, adds to positive 3. Now you'll notice my factors aren't directly above each other, and I did that on purpose because it doesn't matter, okay? They just, if you're going to cancel anything out, it's got to be something from the numerator and something from the denominator. They don't actually have to be right above each other or anything like that. So x minus 1 cancel out. So we're left with an x minus 8 over an x plus 4. And there you go. Okay, so I'll go ahead and stop this one and start another video for the next slide.